Hello, good afternoon. Thank you for attending our talk. I'm Biao He from Ant Group FG Security Lab, and this talk named DataBinding2Shell, Novel Pathways to RCE Web Frameworks. Today, we are going to show our research and findings about the data binding mechanism. First, a little introduction about us. This work is done by me and Hao Wenwu. Both of us are from Ant Security FG Lab, and my colleague Hao Wen is also a CTF player at the Lao team. Well, I'm going to start with the introduction about the data binding mechanism, what data binding is, how it works, and I will show the previous research about it. And then I'll take Spring as an example to detail how we analyze data binding mechanism implementations and the journey of hiding Spring for Shell. And then my colleague Hao Wen will present the different implementations and the design principles of data binding mechanism between different web frameworks, and show some interesting findings. She will also detail how to exploit them to achieve RCE, and finally, some approaches to defense will be provided. Let's start with an example. Suppose there is a URL like this. A user is creating an account, and the user information is sent to the backend as different HTTP request parameters. However, in backend server, this information is stored in a Java bean named user, which is a very common scenario in object-oriented language. So the developers always have to map in the HTTP request parameter to an object instance. Fortunately, some web frameworks do this mapping work automatically. For example, in Spring, the developers just have to create a controller that accepts the user object as a parameter, and the Spring framework will instance it and mapping the HTTP request parameters to the field of user object automatically. In this talk, the process of binding request parameter to a domain object is called data binding. Obviously, the data binding mechanism helps developers a lot and make code cleaner because they don't have to write the random code to construct the Java bean object before using it. As a popular feature, the data binding mechanism is widely implemented by best web frameworks writing in trading language, including Java, JavaScript, Groovy, Python, Ruby, and .NET. However, previous research showed that the data binding mechanism can sometimes cause harm. For example, suppose there is another field in user class which named admin flag. It marks whether the user have admin privilege or not. And when user registry, the HTML form contains the user and the entries only, like in the slide. So the developers expect a URL like username equals hacker and age equals 25. But what if admin equals 1 is also sent to the backend server? There is a low difference between the field admin flag and the other field, so the admin flag will be set automatically too. And now, the user hacker has admin privilege, which is not intended by the application. This is a misassignment vulnerability. This occurs when the attacker is able to access a sensitive field of a domain object, for example, admin's flag in this scenario. So most web frameworks provide a solution to mitigate the risk. For example, in Spring, the developers can invoke setDisAllowed fields method to stop Spring framework from binding the field automatically. But is it safe now? We found that the previous research mainly focused on improper use of data binding. However, the security of data binding mechanism itself has been ignored for a long time. So we decided to conduct research on the security of data binding mechanism itself and see what we can find. First of all, let's choose a great target. Spring framework is the most widely used Java web framework, and there is a low critical security vulnerabilities in the past 10 years. So let's take the challenge and choose it as our first target. The Spring framework provides several ways to map the HTTP request parameter to controller parameters, as we can see in the slide. And how does this mapping works, and what's the differences between them? This is the stack trace of handling annotation at request parameters, and this we can see the stack trace of data binding in Spring. This slide, we can see the difference between them. We can see the data binding mechanism is much more complicated, but does it bring more security risks? To answer this question, we have to find out how data binding mechanism implemented in Spring framework. The key method of data binding mechanism implementation is the method called DoBind of the DataBinder class. For convenience, I prepared a better example to demonstrate how data binding mechanism works in Spring framework. The user class has one extra field address, which is also a complicated object. And when address.ct.postcode equals 30071 is set to Spring application, the postcode of the CT object will be set automatically. Let's see what happened in the DoBind method during the process. The argument of DoBind method is like a hash map. The key of the map is called the property path, and the value of the map is called the property value. They are passed from HTTP request parameters. First, the method checks whether the property path is allowed or required, and then invoke the method called apply property value, which do the main binding works. First of all, the apply property value method split the property path. The property path will be split by separator such as the dot and the left square bracket. This property path is split into 3 parts, and they will be handled one by one. When handle the first part, the address, the Spring framework will get the address from the user object, and the second part is city. The Spring framework will get the city from the object, the address object. And the master will be different. The Spring framework will set the postcode of the city object in one word. The 4 more parts get values, while the last one set values. But how the get and the set values are implemented? We all know that there are 2 types of 2 ways in Java. One is use reflection to access the field, and the other is invoke set or get method. Spring uses the latter. So the next important step is to resolve the get and set method of the Java bin. In Spring, this part is cached in introspect result class. It is implemented by invoking getBinInfo method. It retrieves a BinInfo descriptor from the given target class, which includes the set and the get method of the given class itself and its superclasses. And there is a Java bin specification to specify what information should be included in BinInfo and what should not. And it also specifies what kind of get and set method is a property descriptor. For example, there are 3 sample methods in slides, and the former 2 methods here is a property descriptor, while the third is not, because the return value of the set method should be void according to the Java bin specification. So let's see the property descriptor of our user class. This screenshot, we can see there are 4 property descriptors in the user class, but we can see there is a strange one here. The class, why it appears. Do you remember that the getBinInfo method will retrieve description from the given class and its superclasses? All classes in Java have a common superclass, java.long.object, and there is a get method named getClass in it, which is also a property descriptor. So this particular get method brings a lot of trouble. We can see some security restrictions about it here, and we are going to analyze it later. And let's back to the DataBinding process. After we resolve the get and set method, the next step must be invoke them. Just invoke the set and the get method, then we finish the DataBinding process. But hold on, let's back to the example. The type of the postcode is an integer, but we all know that the HTTP request parameter is a string, so there must be something we missed. Before invoking set and get method, type conversion must be done. Spring Framework handles two types of conversion. One is, as the example shows, convert a string to some particular type, like integer, bool, double, etc. This is implemented by conversion service. The interesting is that we find a particular conversion service. It can conversion string to any class, if only the target class has a constructor which accepts only one string argument. For example, we can convert a string value to a java.net.url object because the URL class has a constructor that accepts one string arguments. This feature do benefit the developers, but sometimes it also causes some side effects. The other kind of conversion is about collections and map objects. The Spring Framework provides the compatibilities to these types. So let's back to the example. When the Spring Framework binding post code is just like the full name pursued code, user.getAddress.getCity.set post code. Okay, now we know the details of DataBinding mechanism implementation in Spring Framework. Let's start to handle bugs. There are four main steps of DataBinding implementation in Spring. Every step deserves in-depth analysis. During the research, we found something interesting when resolving the get and the set method. This slide, we can see there are some security restrictions here, which draw our attention at the first time. This security restriction is the fix of CVE 2010-6022. The if statement is the patch, which is a little confusion at the first glance. This statement filters some get and set method from being invoked. Let's see whether we can bypass it. We all know that the AND operator has more priority than the OR operator. So if condition 1 is true, then the if statement will be true, and the condition 2 and 3 will be ignored. So the problem is there another object which has a Classloader field and can be accessed by get method? And this patch works in 10 years ago, but now is there any changes? The JDK 17 is released. Is there any new features impact the patch? We noticed that the Java 9 brings some big features. One of them is the module system. The field module and its get method has been added to java.lang.class, and so coincidentally, the module class has a get method named getClassloader, which returns the classloader of the current class. So this changes the class and the classloader again by class.module.classloader. So we can bypass the blacklist by class.module.classloader, and now we can manipulate the classloader. This is the most important step of the Spring for Shell vulnerability. And finally, we'll achieve RCE in Spring frameworks. And the exploit will be shown in the first part of this talk. Let's look at the Spring for Shell from another perspective. The CVE 2010-6022 has been fixed by remove dangerous get method. And these dangerous get methods are retrieved from java.lang.class, which means the patch relies on the immutability of java.lang.class, which is a JDK class and maintained by JDK team instead of Spring developers. So when a new get method, the get module is added to java.lang.class, the patch can be bypassed. So I want to ask, is there more cases like this? Your patch relies on something which you cannot control, and nobody promise is immutability, and you will not be notified when the changes happens. I think this kind of scenario should draw more attention by developers and security researchers. Okay, let's back to the DataBinding mechanism. As a fundamental mechanism that exists in lots of web frameworks, we believe that the security risk of DataBinding mechanism is widespread. So we will analyze a lot of web frameworks, and let me switch to my colleague Hao Wen, and she will present what we find.
Hi everyone, I'm Hao-Wen. The rest of this session will be presented by me. Let's start this chapter, more frameworks and the findings. In the previous part, we chose Spring for a lot of frameworks and we finally find Spring for Shell. So we can think about the problem. Do the rest of the frameworks have the similar risk? The answer is yes. We have found some interesting things from the research and choose something typical findings to share. In these findings, the most intuitive is the different data binding implementations in frameworks. So we will start from it. First, we will introduce the data binding implementation of Grails. Grails is a framework implemented by Groovy language and implements the logic of data binding by itself. The implementation logic is mainly represented by the recursive loop processing of the simple data binder. We use the URL sample to introduce its parsing process, which mainly consists of 3 steps. In the first step, similar to Spring, Grails also split HTTP parameters by dots and parses them in order. In the second step, Grails get the get meta property function from the meta class of data binding object to find whether there is a property matching the key of the binding object. Then in the third step, call the set or get method and repeat the previous steps. The second framework we will introduce is Micronaut, which written in Java. In the common data binding logic, the processing logic for HTTP form data and data in special formats such as JSON and XML is different. However, a very special implementation is used in Micronaut. After receiving the HTTP form data, Micronaut will store the form data in the linked hash map, then convert it to JSON node and complete the class recreation through Jackson. This means that even though the content type you pass in is form URL encoded, it is actually passed in JSON format. So the third implementation we want to introduce is the Play framework, which written in Scala. The Play framework select a specific processing class according to the number of fields declared by the class, which completely avoids the hidden fields. However, due to the one-to-one mapping, the Play framework only supports the processing of classes with up to 25 fields. So different frameworks have different implementations of data binding, and these frameworks span different language. Then, their different language features affect the security of data binding. Next, we will introduce it. An important feature of Groovy language is meta-programming, which is very dynamic and open. In this code example, the person class only one name field, no setter or getter functions, and the name field is provided. In Groovy, after instantiate a person, we can directly access the provide attribute name and assign it a value. Therefore, the provide property of Classloader can also be set directly, such as pass in UCP. Another important feature of Groovy is that meta-programming introduces more properties than Java. For a common class, the Grails framework have many additional properties such as meta class, meta property values, and so on than the Spring framework. These additional attributes are related to Groovy's meta-programming. In fact, there are also well-known vulnerability caused by the similar root, such as prototype pollution in Node.js. In this code, there are 2 properties in the demo class, but in Node.js, it also automatically inherits some implemented attributes such as the proto. In addition to the demo class, common objects such as strings, number, and arrays also automatically inherit the proto attribute when they are created. The prototype pollution attack make use of this language feature in Node.js. After introducing the different framework implementations and the language features, we turn our attention to the security restrictions of the data binding mechanism. In the first fix for Spring, the main layer is to add 3 new blacklists. With the help of these new blacklists, the access to the Classloader attribute of the class type is blocked. In the next repair for Spring, it added a lot of whitelists, which strictly restrict
Hi, we can't hear you. Oh. Just hold 1 second. Just wait 1 second, please.
And we know that the vulnerability of the data binding mechanism can only be established through unexpected field access. Therefore, the data binding mechanism is secure under the strict mapping mechanism of the Play framework. This is a strange but safe practice. In the Grails frameworks, both whitelist and blacklist are implemented in the security restrictions of the data binding mechanism. In this code, proper name represents the content of the parameter key passed in from the HTTP data. Whitelist and blacklist are arrays manually specified by the developers, and the content is specified field name. We previously introduced a type of vulnerability which called mass assignment, and took Spring as an example to introduce how to defend it through setDisallowed field. However, setDisallowed field is not flawless and can also be bypassed. Before data binding, Spring will determine whether the key matches the value in setDisallowed field. This matching process is case sensitive. When binding field, Spring will convert the first letter of the field name and to uppercase and lowercase if the specified field cannot be obtained from the object, and retrieve the field again. This means that the case of first letter of the field name will not affect the actual binding logic, but will affect setDisallowed field. Therefore, we only need to capitalize the first letter of admin flag to complete data binding while bypassing setDisallowed field. Next, let's continue to look at the security restriction bypass in the Grails framework. Due to Groovy's language features, there will be many potential attributes when data binding is performed. For the book object, the properties that can be bound include the title, meta class, meta property values, and so on. For the title field of the book object, the potential attributes will also be automatically inherited. So you can access these potential properties and find the inherited properties of them. In the exploitation of data binding, the common idea is to find and manipulate the Classloader. For this code, you can bypass the blacklist and whitelist restrictions to obtain the Classloader attribute in this way. We also found some interesting features when digging for vulnerabilities in the Spring framework, such as constructor calls occur during the type conversion and multi-part body parser with a lower of RFC. In this example, we need to convert the string to URL. The core logic has two parts. The first part is to select the conversion method according to the source type and the target type. When certain conditions are met, the constructor of the target type will be returned. The second type is to instantiate through the constructor. If the target type at this time is not a URL, but a class customized by developer, the constructor of this class will be triggered, which may cause potential security problems. In the multipart of upload request, Spring obtains the file name of the uploaded file through the file name parameter. In the process of file name parsing, there are also some unknown special formats. When we start with file name, the following content will be separated by single quotation marks and parsed with specific logic. The first part is the charset used for parsing, and the third part is the URL encoded value of the actual file name. When parsing, this encoded value will be converted into the corresponding text. So if we upload a file with such boundary, what will the file name be? Actually, the last part will be identified and the file name is parsed with specified charset. In this case, is UTF-8. Even if we replace the position of file name attribute, the result will be unchanged. And now, let's exploit. In Spring4Shell, we can modify the value of Classloader attribute through the model attribute. How can we make use of it? One scenario we found is Tomcat work package. In this scenario, the first question is, what is the difference between the Classloader in the fat jar and the work package deployment? When accessing the Classloader property of the model, the type of Classloader in work package deployment is web app Classloader. And web app Classloader is set separately for each container. Therefore, different web containers will have unique web app Classloaders with different configurations. The first exploitation we will introduce is arbitrary file read with web app Classloader in Tomcat. The app-based attribute determines the directory that the root actually points to when accessing the application. We can directly access the system root directory by setting the value of app base to the system root base. At this time, we can read the content of the specified file by setting the URL to the absolute path corresponding to the system file, such as etc password, and now the page returns the content of etc password. When trying to RCE with web app Classloader, we need to use the access login mechanism of the web container. Access log web is a login mechanism that creates log in the specified format and supports the configuration of multiple attributes. By setting the suffix attribute, you can control the suffix of the created log. For example, when it is set to JSP, you can change the generated log file into a JSP script. The pattern attribute can control the content of the generated log file. Setting the runtime code to pattern can make the generated log contain this malicious code. When setting the content of pattern, we use two special values. What are they? In the document of access log, data in this format means that data is obtained from the specified HTTP header. We set FG and lib, so we take values from the FG and lib in the HTTP header. Why do you want to set it in this way? Because the left bracket and % cannot be directly inserted into the file content by pattern. File date format is the time rule for log file creation, which plays a key role in determining whether the log file needs to be regenerated. If the file date format is not matched with the current timestamp, the log file will be recreated. We set file date format to a value different from the default value, such as 4Y, which means the log file name is expressed in years. Since no log file of this format exists by default, the generation of the log file will be triggered. This technique of modified Classloader has appeared in 2014. Similar operations can be seen in the use of Struts too, and we will use it in Spring4Shell. But Tomcat has repaired this exploitation. Tomcat breaks the access chain of parameters by setting get resources to null, which leads to the failure of the exploit. In many introductions to Spring4Shells, restrictions on exploit were mentioned. However, these restrictions are not all correct. Actually, Tomcat Word Package deployment is only an available situation, and there are other available ways. We will take Glassfish and Payara as examples. For the same resources attribute, Tomcat represents web resource root, while Glassfish and Payara represent another class. So what's the difference between them? There is a property named dir context in proxy dir context. The actual implementation of this property is web dir context. In web dir context, there is an attribute named base, which represents the absolute path when the current web container is accessed. By setting the base attribute, you can control the system absolute path that the home page actually points to when accessing the web container. It should be noted that the attribute needs to be accessed with doc_base. Therefore, if the doc_base attribute is set to etc, the etc password will be downloaded when we access the same file name. Another exploited way of data binding is remote class loading. We will use Grails as an example to introduce how to exploit. In this exploitation, we set the char set attribute that does not exist by default in the content type of the HTTP data, such as evil. Since this char set does not exist by default, Grails will traverse all jar paths to find it. Through Grails data binding mechanism and Groovy's language features, we can modify the provide properties of Classloader. In our exploitation, we need to set 3 properties of the UCP attribute to the same remote jar file address. The evil jar file is the malicious file we construct. The evil jar is used to provide the evil char set service. The evil class extends char set provider and insert malicious code into the function. At the same time, the SPI mechanism enables the char set to be automatically discovered when the application is looking for char set. When we specify char set as evil in the HTTP header, application will automatically trigger the logic of loading the char set and execute the command to achieve RCE. In the example of malicious use through char set, we set the path of the UCP attribute to the HTTP address, starting with the jar protocol. If we send the request twice in sequence, and the second request send an address in the evil protocol, what will happen? Since there is no processing method of evil protocol by default, Grails will generate a handler class name based on evil protocol for loading. Therefore, when searching for classes, application will finally find them in the remote jar address we have set. Therefore, we only need to create a class in the evil jar with the same name and insert malicious code to achieve RCE without the char set mechanism. Now we reach the final part, defense and takeaways. We can think about a question. What these vulnerabilities have in common? The first is open. They accept data from arbitrary user. The second is dynamic. They make use of dynamic features of programming language. The last is deserialized. They all convert byte stream to object. Combine their first letters, we also call it ODD vulnerability. The concept is from deserialize, but not only deserialize. We can summarize some approaches to defense possible attack in the data binding mechanism. For developers, we have the following suggestions. First, try to use whitelist instead of the blacklist when you write the defense code. For example, Spring finally used whitelist to defend against the problems of data binding mechanism. Second, be careful with programming language features. They may betray you. Programming language features can bring many convenience for developers, but they also introduce risks. For example, in Grails, we use the language features of Groovy to complete the modification of provided properties of Classloader. Third, developers can defend by breaking the attack chain. For example, Tomcat sets the value of get resources to null and deprecates the function so that invalidates all exploits that rely on the resources field. In our talk, there are three key takeaways. First, you will know the methodology of analyzing the data binding mechanism written in different programming language. And then security researchers can get some new exploit technicals and tricks to achieve RCE. Last, developers can understand the security design principles of data binding and know how to prevent security bugs. Thank you again for being here. If you have more questions, you can contact us with Twitter. Thank you.